record. Yes. So the Australian session is still ongoing. So we maybe some of the attendees of the Australian session will be coming soon to our session as well. So thank you very much for joining again. And okay, so I want to start for the Japanese session. So Japanese session is we are setting the session name to the challenge to establish carbon neutral and Jyunkangata society with environmental system analysis. And actually, the environmental system analysis is our Japanese side of the academic society, the name of academic society under the civil engineering society. And this session is a joint online event with JSCE, Japanese Society of Civil Engineers, Environmental System Committee. So we are thinking about the environmental system analysis contribution to the industrial ecology for the current industrial ecology's research is in Japan is some of the research is very much linked to the industrial ecology, to the our environmental system analysis. So today we asked some of the member from the JSCE Environmental System Committee. Firstly, I want to introduce Professor Fujita Sensei from the Tokyo University. He was previous president of the JSCE Environmental System Committee. And also the藤田先生、どうぞよろしくお願いいたします。
Thank you.
And also second speaker will be Professor Seiji Hashimoto from the Ritsumeikan University. He also is part of the Environmental System Committee. He will, yes, 橋本先生よろしくお願いいたします。And also the Professor Osamu Saito from the principal policy researcher of the IGES. 斉藤先生よろしくお願いいたします。はい。
よろしくお願いします。
お願いします。So then I want to open our session. Firstly, I want to invite the Professor Tsuyoshi Fujita from Tokyo University. And he will talking about industrial symbiosis and the circular economy towards carbon neutral society. 藤田先生、どうぞよろしくお願いいたします。
はい、Thank you, Professor Tanikawa, and good morning or good evening and good afternoon, ladies and gentlemen. It will be a great honor to have the opportunity to make a short presentation to wrap up the circular economy as well as industrial symbiosis accomplishment in Japan, also the ongoing academic challenge to apply that into the new carbon neutral future society. So this will be a kind of the very simplified the timetable of the circular economy and the Japanese policies, and maybe the ISIE and all the international society may have start discussing about the concept and the philosophy of industrial ecology from the late 1980s or early 1990s, and we learned a lot from those years. And then industrial symbiosis or eco-industrial development has been considered from the beginning as a practical implementation part of industrial ecology. So many countries have a good, keen interest to introduce the project of the eco-industrial development. Particularly Japan started our national initiative of eco-industrial development named as Eco Towns from 1997. And as maybe Professor Hashimoto may talk a little bit more in detail later, the Jyunkangata Shakai, or the recycle-oriented society basic law, has been enacted shortly after that. And ecotowns has been a kind of the local development policies to utilize the circular economy into the regional economic revitalization. So maybe I have two parts of today's presentation. One would be to wrap up the eco-industrial development in Japan, or the eco-town in Japan, and particularly for those who haven't touched so frequently with Japanese experience, but which has been already presented in the series of ESA meetings or industrial symbiosis charters directed by Professor Chato in the Yale University for several years. So maybe I may appreciate you would allow some of the duplication of my presentation here today. So the eco-industry development and our eco-towns was a kind of idea to transform the industries from the left-hand side, one-way type, the industrial system, deeply depending on some natural resources, towards the right-hand side and more circular industrial system to utilize the byproduct as a substitution of the natural resources. So this will be a kind of the conceptual diagram we draw around 2 decades ago for the perfectly circulating industrial city in Kawasaki. And then Japan started their eco-industrial development initiative and spending a lot of the national subsidization and designating the 26 eco-towns, national eco-towns all over the world from the 1997 toward 2005. And the lot of variation has flourished as a part of the development of the industrial symbiosis practices here in Japan. As one was more oriented with the material industry that would be converted into some more circular arterial industries. And also some cities, some eco-towns were focusing more with some collaboration with the urban sectors. And some was specialized in the collecting a lot of the waste, and that would be a kind of considered recycling factories, the basis of the nation. And also another eco-towns or eco-industrial parks in Japan was focusing on the rural circularization as well. So we have seen a lot of the practices and development of those eco-industrial development in Japan. And then we made several quantitative analysis. That would be a kind of picture of the Kawasaki eco-towns, which is one of the representative demonstration of eco-industrial development in the country. And we made, as a part of environmental system research, we made a quantification of the multiple recycling facilities, namely, as you could see here, as a kind of life cycle chart. And there have been a lot of different type of the recycle plant, like waste plastics recycling and waste paper recycling and waste steel recycling, as well as the circular cement industry. So we made a life cycle oriented analysis and quantification of those the ecological flow, and made a kind of quantitative evaluation of the impact of the eco-industrial parks. In this diagram, this would be some material flow of the Kawasaki eco-industrial park by accumulating the different types of recycled facilities. We made some quantitative analysis of those industrial recycling facilities, and we made the aggregated those impact, and we show those kind of recycle effect, circular effect to the decision makers or policy makers in the country. And as Japan, as I already told, that Japan has already initiated the 26 national eco-industrial parks, and including Kawasaki as a part of representative. And also they have developed around 200 recycle facilities all over the nation. With a good collaboration of the national government, we made some the analysis of those 26 cities and 190 facilities, and we could have made some national scale material flows, and we could identify what was the circular effect of the eco-industrial parks as a nation, as well as we could identify some decarbonization effect of the circular economy or eco-industrial development of the 26 eco towns, as well as 190 recycling facilities all over the nation. So we could find out another the academic finding. Maybe I would show a little bit in three features. One would be the economic impact, and by making a national scale survey of all the 26 eco towns, 190 recycling facilities, we could identify that they consumed the $600 million national subsidization, but they could also make up some three types more private economic effect. So that would be a so-called multiplier effect. By getting some public investment for the recycling facilities of eco-industrial development, that we could observe some 3 times more economic effect as a kind of private investment. That kind of multiplier economic effect was a kind of finding, and the information we could share as a contribution of the eco-industrial development of the industrial ecology. Also, the distance was a kind of findings. We could identify the average distance of the recycling of different materials. And then, as you could see, some material would be circulated in the distance of 20 kilometers, some would be more than 100 kilometers. So then we could provide a kind of idea that eco-industrial parks should not be closed in the industrial parks. Maybe they should be connected with cities as well as the region. So then we propose the idea of the eco-industrial the eco-industrial park was the symbiosis, urban symbiosis as well. Maybe rather than closing the industrial sectors inside of their industrial zones, maybe we should think about the future effect of the combining the urban sectors or the regional sectors with industrial facilities. And then we could make a kind of optimization analysis of the optimal distance of the recycling. That would be a kind of spatial analysis in the Tokyo metropolitan region. So we could identify some optimal scale of the recycling facilities of the plastics here in the Tokyo metropolitan region. So then we could propose a kind of the different recycle area, recycle the eco-industrial circles, or maybe we made some kind of idea of circular regions. So then we each region should think about the appropriate scale of the recycling or circular economy, considering their consumption patterns as well as production patterns. Then at the same time, the low carbon effect or decarbonization, carbon neutral effect was a kind of concern of the industrial symbiosis analysis. This will be a diagram which we made for the Kawasaki, so-called some synergy network with imitation of the synergy network of Kalundborg in Denmark. Then we made a kind of comparison between Kalundborg and Kawasaki. Maybe allow me to skip some of the information. But the idea was, in case of Kalundborg, the energy circularization or heat circularization was a kind of good practice. As you could see, maybe Kawasaki may have a more material circularization as a kind of practices in these diagrams. But maybe in Kalundborg, they could have made a more large scale the energy circularization. So then idea was extended towards some policy design that maybe we can develop the idea, develop the practice of eco-industrial parks, starting from the circular economy for the material recycling. Then they can extend towards the energy network. So this is a kind of proposal or tentative calculation of the Kawasaki eco towns, and we could we made a simulation that how much carbon dioxide can be reduced by the developing the so-called the carbon neutral combinat or carbon neutral eco-industrial parks. But this will be still undergoing the research, and we are still discussing a lot with some policymakers in the government. So then, but still the Japanese government have started to extend that kind of demonstration project, starting from the policy scheme from one or several demonstration cities, and then develop that, extend that towards the national scale. That was the idea of eco-towns, eco-industrial parks development in Japan, but also they are developing that idea into the eco-model cities for low-carbon society, or the SDGs future cities would be the latest the initiative by the national government. So the environmental system research group in the country are trying to develop to provide some academic, the scientific tools to support those planning. So here we with the Professor Tanikawa is joining this project, and with several research institute as well as the university, we are trying to propose those kind of the planning support methodologies, starting from the diagnosis of the current situation, and maybe to make some future scenario simulation of the optimal decarbonized society, the future, and then to design some demonstration projects, starting from the eco-industry development or some decarbonization industrial system. So this will be a kind of the future scenario simulation, which we developed spending several decades, and with utilizing those integrated model, and we can provide some equilibrium future simulation for the different future scenarios. This will be providing some future target of the 2050 for the one local government in Fukushima prefecture. Then identifying the future target of decarbonization future of the 2050, and we may be able to choose some appropriate options. Maybe the eco-industrial parks would be located around here, but we need to discuss about some energy system as well as transportation system and some social system. Maybe for the industrial ecology society, in order to make a virtual contribution to the low carbon realization. So maybe we should have a more inclusive and integrative scope of that kind of technology options or some evaluation system. So that kind of idea can be also extended to the SDGs. Maybe SDGs, our circular economy or the industrial ecology would be located on the target 12 of the SDGs, but that should be connected with a lot of different targets like climate change 13 or energy 7 or industry 8 or 9 or the community, the partnership of the 17. Those kind of integrative approach may be a kind of concern of the future research contribution from the environmental system or industrial ecology. So the final part would be a kind of DX, and maybe the smart monitoring of the eco-industrial parks or industrial ecology might be getting more and more realistic. So maybe to utilize those kind of real-time data and to get some real-time simulation, those kind of new generation of the research might be something we can expect to let the industrial ecology community to make a contribution in the near future. Okay, so I appreciate your good attention, and I would like to complete my presentation here. Thank you for your attention. Thank you.
Thank you very much, Fujita-sensei. It's a quite interesting and also quite useful inputs to our special session from Japan. And also I did post it about our Ecotown project, the official leaflet from the Ministry of Environment, so that you can download from the Dropbox link as well. Okay, Fujita-sensei, thank you very, very much for your contribution. Okay, so next I want to invite, we will have some small discussion after the whole presentation if we have the enough time. So the next I want to invite Professor Seiji Hashimoto from the Ritsumeikan University. So Seiji, we're talking about the Jyunkangata society towards integrated carbon neutrality. Hashimoto 先生、どうぞよろしくお願いいたします。
Thank you very much, Tanikawa sensei. Today I'd like to talk about the Jyunkangata Society concept because today's session's name includes Jyunkangata Society and it's Japanese. And also I'd like to talk about the direction for integrating carbon neutrality into the Jyunkangata Society development. First, what is Jyunkangata Society? Actually, now it's circular economy. The term circular economy is becoming very popular, but we, Japan, use this term, Jyunkangata Society, from the beginning of 1990. Jyunkangata Society can be divided into three parts. First one is Jyunkan, which means cycle, circulation, recycling. Gata means oriented base types. And so direct translation of this term, Japanese term, is cycle-oriented society, or recycling-based society, circulation type society, and so on. This concept has two main cycle concept. One is cycle in the natural environment. The other one is natural cycle in the socio-economic system. The cycle in the natural environment includes the cycles of the material cycles in the environment, including nutrients such as nitrogen, phosphorus, and also cycle of the carbon in the natural environment, a cycle of water in the natural environment. At the same time, cycle means cycles of the situation. For example, we have seasons, 4 seasons, spring, summer, winter, autumn, winter. Those cycles are also included in this concept. The other one is material cycles in socioeconomic system. In other words, it's recycling in the socioeconomic system. This is a definition of Jyunkangata Society provided by the 1990 report by the Committee for Jyunkangata Social System for Environmental Protection. This committee was organized by the Environment Agency at the time to the contribution to the Rio Summit in 1992. This report says to achieve sustainable development, the way of economic activity that fits to a great cycle in the ecosystem must be designed and practiced. To this end, it's necessary to restrain the input of primary resources to minimize the amount of emissions to the natural ecosystem, and to prevent the emissions from disturbing the environment by putting a higher priority on reuse and recycling than disposal. Such economic system can be called a Jyunkangata Society. As you can see, there's two cycles in these sentences. One is cycle, great cycle in ecosystem. The other one is reuse and recycling. So the objective of Jyunkangata Society is to protect, maintain the great cycles in ecosystem by reducing the input of primary resources and reducing the amount of emissions to the environment. To achieve this, reuse and recycling is quite important. Many Japanese scholars used different translation of Japanese term, but now official government, national government's official translation of this term is sound material cycle society. a healthy material cycle society. And today I'd like to talk about direction for integrating circularity, carbon circularity into Jyunkangata society development. After the Prime Minister Suga's speech indicating carbon to realize carbon neutral society by 2050, a lot of discussion has been triggered. And just a few months after the declaration, the Green Growth Strategy for 2050 carbon neutral was formulated, which selected 14 priority areas where growth is expected toward 2050, and resource recycling industry is also one of them. Just after 1 year of the declaration, Cabinet decided new plan for global warming countermeasures, which to achieve carbon neutrality by 2050 and 46% emission reduction by 2050, 2030. And to contribute to the formulation of plan for global warming countermeasures, Central Environmental Council Jyunkangata Society Committee has started a discussion about the medium to long-term scenarios in the resource recycling and waste management field toward carbon neutrality in 2050. And this discussion continues even after the formulation of the new plan. I would like to quickly introduce the greenhouse gas emissions from waste sector in Japan. It's about 40 million tons CO2 in 2020, leveling off in recent years. And it's about 3% of the total emissions, greenhouse gas emissions of Japanese economy. And I think it's the characteristics of Japanese greenhouse gas emissions from waste sector is that emissions from 1A, the category 1A, waste incineration with energy recovery, and 5C, incineration and open burning of waste are quite large, these blue parts and yellow parts. And 1A, the blue parts are increasing. And emission, on the other hand, emissions from 5A, solid waste disposal, solid waste landfill is decreasing because of the drastic reduction of the waste landfill in Japan from 1990 to the current level. So main target of the greenhouse gas reduction from the viewpoint of waste management is the reduction of 1A and 5C, the waste incineration with or without energy recovery. I think the measures to achieve the carbon neutral from the viewpoint of resource recycling, the waste management, the scope can be divided into three. One is greenhouse gas inventory, which means decarbonization of waste incinerated and landfill. The second one is related to resource recycling and waste management process, which means decarbonization of energy related to resource recycling and waste management. And the third one is contribution of resource recycling and waste management to low carbonization and decarbonization. Of course, from the viewpoint of industrial ecology community, decarbonization through resource efficiency is quite important. But today, I'd like to talk from these three viewpoints. The first one is decarbonization of the waste incinerated in landfill. Conditions for the carbon neutrality, we must stop the burning of fossil fuels, including waste plastic, oil, and tires, fiber, synthetic fiber. As you can see here, CO2 emissions from 1A and 5C, the most of the emissions comes from incineration of plastics and also waste oils. So we need to reduce the incineration of these. As for the landfill, we need to stop the landfill or the biological materials. So to achieve the carbon neutrality, fossil materials should be reduced in use or replaced with biological materials or recycled as materials or landfilled or stored as it is. For the biological materials, we need to recycle primarily as materials. And if it is not applicable, we should use it as energy sources. And industrial ecology community in Japan contribute a lot for the formulation of this inventory, greenhouse gas inventory. An example is recycling of plastics. Regarding plastic container packaging, there's greenhouse gas emission reduction effect, as shown on the right side figure. This figure shows CO2 emission reductions per tons plastic waste. And as you can see, any type of recycling methodology, including mechanical feedstock and energy, we can reduce the CO2 emissions. And this assessment include indirect effects. So from the life cycle perspective, it's rated to the third scope, but recycling is quite important to reduce direct reduction of emissions from incineration of the waste. However, this contribution should be noted that substitution effect assessed here will also be influenced by the decarbonization in the original process. So we need to update those assessment of the reduction effect of the recycling. And industrial ecology community in Japan also contribute a lot for the assessment of these recycling system. The second one is decarbonization of energy related to resource recycling and waste management. For the carbon neutrality, we need to decarbonize the energy to operate or collection track, heavy machinery, sorting, incineration, and recycling facilities. So we need significant energy savings, efficient collection and transportation, and also electrification of energy sources and using carbon neutral power, and converting fossil fuels into biofuels. Typical example from the energy perspective related to recycling is decarbonization of paper recycling process. This figure shows the comparison of energy use in paper manufacturing. Total energy for paper production is non-recycled paper is bigger than recycled paper. So we can reduce energy consumption itself through the recycling of the paper. But greenhouse gas emissions from fossil fuels non-recycled papers emissions is smaller than the emissions from recycled paper. Because black liquor, which is taken from the wood chips from in the paper manufacturing process, is used as a biomass energy in the paper production process, pulping and paper production process, which is more than 50% of the energy consumption, total energy consumption of paper manufacturing. And so from the viewpoint of fossil fuel consumption, production of paper from used paper is larger than the paper production from the wood chips. And so we should reduce those fossil energy for the decarbonization of the recycling process. And the significance of the paper recycling, including forest conservation, increases through decarbonization of energy for recycling. those analysis is quite important and which we can contribute from the industrial ecology community. The third one is contribution to decarbonization through resource recycling and waste management. And conditions for carbon neutrality, we need to decarbonize the energy supplied from waste. And the concrete approach is include but biogasification of waste, food waste, sewage sludge, etc., or using waste, biomass waste as energy source. Also, we discuss a lot not recently about industrial use of incineration heat. Japan is one of the countries where many of the waste is incinerated all over Japan. And those facilities are usually located in remote place. So there's no demand around those facilities. And now we are discussing how we can move those facilities in remote place into the central area, especially in the industrial area, to utilize incineration heat from incineration heat. Also, it's not contribute to the carbon neutrality, but low carbon promotion of waste power generation and improvement of power generation efficiency. Now, the power generation efficiency of the waste incinerator is about 40%, and we are trying to increase this efficiency. And the other is production of hydrogen by waste power generation and biocarbonization of biological waste. Those are the option of the measure to the carbon neutrality and low carbon society. And this figure shows how much contributions can be provided from the waste use as an energy source. At the bottom, power generation at the household waste incinerator, waste oil as fuel, waste wood as a fuel, shows significant contribution to the reduction of the fossil CO2 emissions as a substitute of the fossil fuel. Industry ecology community in Japan also contribute to these national base assessment of the contribution of the recycling process. The final one is also about the contribution to decarbonization or low carbon, which is the contribution through recycling, including reduction of greenhouse gas emissions from industrial process. I put two examples. One is steel making and cement production. There's a CO2 emissions, industrial CO2 emissions, industrial process-based CO2 emissions. So recycling metals, of course, save energy and CO2 emissions, but at the same time reduce CO2 emissions from reduction reaction of iron, aluminum, and lead and zinc, etc. And also, in addition, the promotion of more advanced recycling, including alloying elements, leads to further CO2 reduction. But if the process switch to hydrogen reduction, the effect of recycling will decrease. So we need to catch up those situation of the original process to appropriately evaluate the contribution of the resource recycling and waste management. That's all from my side. Thank you very much.
Thank you very much, Hashimoto-sensei. It's a quite important input about the Jyunkangata society and also Japanese society knows regarding to the material cycles as well. Thank you very much, Hashimoto-sensei. And then, okay, thank you very much. And also, we want to invite the Professor Osamu Saito from the IGES. Saito-sensei, よろしくお願いいたします。
Okay, good morning, everybody. Thank you for joining this Japan session. So I would like to add the kind of different flavor to this session from the perspective of the biodiversity conservation or nature restoration. So when it comes to promoting the Jyunkangata shakai or the circulating society, we also need to consider the how to make it in harmony with nature. So from that perspective, I would like to provide some of the research, previous research project and also the 2 ongoing projects. So first, I would like to start the previous project, which conducted from 2016 to 2020, and now we are preparing the project starting from this year. And there also the last 2 projects are ongoing project, but those are all kind of quantifying ecosystem services in harmony with nature, and also the promoting the integration of the Jyunkangata shakai and the nature conservation. So the first one, we call it PANSES project, is predicting, assessing natural capital and ecosystem services, starting from 2016. And the objective is to develop a kind of integrated assessment model or socio-ecological systems to predict the change of the natural capital and ecosystem services up to 2050 at both national and local scale, considering the 4 major crises in biodiversity identified by Japanese government, which namely the overuse of the nature and underuse of the nature, and then the third one in the introduction of the invasive species, and third one the global change, including not only the temperature rise but also the ocean acidification. And we have the four teams. But under each team, we have like 3 or 4 sub-teams. So in total, the 15 research teams contribute to this project with more than 100 researchers in Japan. And then this is a kind of schematic diagram to explain the kind of integrated model. So starting from creating the future scenarios, so we created the 4 different scenarios, which I will explain a bit more. And then based on the 4 narrative scenarios, we also developed the population simulation, population models, and also land use models. And based on the population and the land use model, we also estimated terrestrial ecosystem services and marine ecosystem services. And also, so these are some of the examples of some of the ecosystem services we quantified, like rice, vegetable, timber, fruits, carbon, sedimentation, pollination. And also in terms of the cultural services, we also quantified the camping services and the environmental education services. And in the same way, we also quantify the major ecosystem services provided by marine environmental ecosystem. And we also quantify the interaction between terrestrial and marine ecosystem services. And then also the different ecosystem services also quantified into the socio-economic values. And when we conducted the scenario analysis, we also considered some of the policy options in the terrestrial environment and also marine environment. So for example, in the terrestrial ecosystem, we consider the conservation of the abundant farmland, etc. And this is 4 future scenarios. We created 4 scenarios based on the population distribution. So either that we promote more urban compactification versus population dispersal. So the more people still live in the rural area versus the more people in the urban area, living in urban area. And the other axis is not either people depend upon the more natural capital versus people more depend upon the produced or the imported goods and materials. And then then we ended up for different scenarios: natural capital-based dispersed society, natural capital-based computer society, or produced capital-based computer society, or produced capital-based dispersed society. And based on these four scenarios, we also developed predicted both population change and land use changes under the four different scenarios. With the spatial distribution is 500 meters. We started from 1 kilometer grid, but by the end of the project, we downscale it to the 500 meters at Japan scale, at the national scale. And this is more the detail of the how we, what the difference of the land use change of the difference and population distribution difference depending on the comparing the BAU, business as usual. I'm not going into detail, but these we use the 9 land use classification, residential area to the plantation forest and others. And as you see, the secondary forest and plantation forest is significantly different depending on which scenario we choose. And also in the compact scenarios, we find more population, the decrease in the rural areas because the people move from rural area to urban area. That means more zero population area will increase in the rural areas. But if we choose the dispersal scenarios, the more we can decrease the zero population grids, which means that more and more people can still remain living in the rural area. And at the same time, in terms of the conflict between the mega solar power plant and the land cover change, so this is, I think, one of the important outcome relating to the circular economy or circular society. So if we promote renewable energies, there is a conflict between the land conversion from the natural forest to the solar PV. So at the national scale, we found that many of the forests that converted to the mega solar. So we checked all the mega solar. One of our research team checked the mega solar, the land cover conversion, and we found that many of the natural forests are converted. And also the pattern is different depending on the region, but in overall, these are also contribute the loss of the key ecosystem services in the rural area, especially in the forest conversion, because of the forest conversion. And by using the 4 future scenarios, as I mentioned, that we also predicted the change of the rice production due to the improved productivity and also the increased crop area. But that's impact is very marginal compared to decrease due to the reduced productivity, decrease due to the cropland. And also we consider that different climate RCP scenarios. And so combination of the RCP scenarios and also the productivity change over the time, we found that there are more the negative impact. So the production of the rice will decrease under the many of the scenarios due to the both climate change and land use changes, and also land abandonment. Farmland abandonment, and also that's a major impact in Japan. And this is overall the summary of the all terrestrial ecosystem services. So left-hand side, these are the different type of the provisioning services from the water quality, spinach production, rice production, cypress and the cedar. So these are plantation forest productivities. And then also the regulating services include water qualities. And in terms of cultural services, we control education, camping, and hiking. And then as you see, most of under the many scenarios, and also these are the different regions in Japan. And we also divided metropolitan and rural. And you see the in most of the cases, regardless of scenarios, it comes below the BAU, which means we may lost these ecosystem services under most of the scenarios. There are some of the positive, the increase or the improvement under the different scenarios, but in terms of the provisioning services, we found many of the provisioning services may decrease under any scenarios. So these are something we also need to consider to when we promote this Jyunkangata Shakai. And then I got to skip here. And then we also did some international or local outreach event, including the summer school in Switzerland for the PhD students. And we also organized local event to disseminate our research findings. And then toward the end of the project, we also developed this series of the policy briefs and also the journal special issue from Sustainability Science Journal, not the journal with industrial ecology, unfortunately, but maybe in the future, we will also consider the special feature from the industrial ecology. And also, we also published the book from the project. And now we are preparing the new, the project as a post-Panses project to further expand our integrated model to more explicitly capture the climate change impact, and also to try to consider the indirect driver. So, so it used to, we only consider this direct driver and then also the biodiversity the lost. So only the land use change and climate change has been considered, but we also need to consider the indirect driver behind the direct driver. So that is one of the major difference from the previous Panses project. So in the new project, we would like to consider these indirect drivers by using agent-based models and other the updated advanced models to quantify the impact by the indirect drivers to the direct drivers. And we also conduct a national scale, the simulation and also the local scale simulations in the 3 different local sites in Japan, and also the urban areas too. Then rest of the time, I would like to try to wrap up my presentation, just showing a few progress of the 2 new projects. So one is the integration of the traditional modern bioproduction systems for sustainable resilient future under climate ecosystem changes. ITMO project. It's a collaborative research project in Japan, Philippines, and Indonesia. And we try to come up with a kind of hybrid system of the traditional bioproduction system and the modern bioproduction systems. So these are some of the examples of the production systems, like plantation versus home garden, or agroforestry versus the tree plantation, etc. So these, and then the hybrid system is also proposed and we are now working on the developing the future scenarios and also the building the models to assess the impact of the population, land use, and ecosystem services. At the same time, we organized, we developed the database for the bioproduction systems. Okay, so for more detailed information, you can see this the website. And this is the 3-year project, so we have 2 more years to go. So I hope I can share more of the result sometime later. And this is another 3-year project, in collaboration with the United States, also France, Italy, and Taiwan, and Japan, the 5 countries collaborative research funded by Belmont Forum. This project focuses on the land abandonment. So the farm abandonment, forest abandonment is also one of the key phenomena not only in Japan, but also the other the developed countries, including United States and Europe. So we focus on the land abandonment and then also try to understand how it impacts on the natural ecosystem and also the social society. So these are case study areas, and then again we have the website. So if you are interested in it, you can find more detail in this website. So thank you very much. I would like to finish my presentation. Thank you, Tanikawa sensei.
Thank you very much, Sato Sensei. It's quite very much input about the ecosystem service, and also it's also very much nice project introduction. It's really appreciate about that. Thank you very much, Sato Sensei. Okay, we have almost like 3 more minutes about to go. We will maybe Chinese session will be start from the next 3 more minutes. So okay, so panelists and please, Hashimoto Sensei, please open your video if you can, and maybe we can wrap up our sessions. So Fujita Sensei and also Hashimoto Sensei and Saito Sensei, thank you very much for the very important input. And I want to invite from the floors, maybe 1 or 2 questions. Maybe 1 question is maximum, so that anyone who want to raise a question to all our panelists today from the Zoom. Okay, so I want to ask the 3 panelists that just for the future plan regarding to the Jyunkangata society and also carbon neutral society and also ecosystem service of your plan regarding to the environmental system analysis point of view. So that's quite important to our Japanese society regarding to the industrial ecology side. So please give us several comments regarding to the future plan of your research and also your aspect regarding to the environmental system analysis as well. Sensei,
Okay, thank you, Tanikawa, Professor Tanikawa, and it will be quite profound question, but maybe if you allow me to provide 1 minute information to your question, maybe the environmental system or the industrial ecology was a kind of the crystal accomplishment between the theoretical theoretical consideration with some practical implementation. So now the circular economy and the carbon neutral seems to have moved from the concept towards the action. So maybe one of the expected contribution from environmental system or industrial ecology community to the society would be to provide some showcase type demonstration project, either in the biodiversity preservation or some circular economy development, or maybe industrial symbiosis project. And that should have a more inclusive scope, like SDGs or some 3-dimension you suggested. So those kind of the mixing the future the target with some the mid-term demonstration project would be a kind of the request from the society to our research group. So maybe let me complete here. Thank you.
Thank you very much. Thank you very much, Sensei. Hashimoto Sensei, いかがでしょうか?
Personally, I'd like to I'd like to talk about 2 points. One is how to evaluate the new business, including sharing, servicizing, those type of business. Still, we have clear evaluation methodology. And so discussing further about that aspect is quite important in the field of industry ecology. The second one is indicator to evaluate the integration of circular economy and or sound material society and carbon neutrality, how to measure and how to check the progress of the society. That is the two, どうでしょうね。main challenge now we are facing in industry ecology community.
Yes, yes. Okay, thank you very much, Hashimoto Sensei. And Saito Sensei,
Yeah, that time is over, but yeah,
no, fine.
1 minute. Yeah.
We have just small question to you from
Okay.
the panel. How did you investigate the social impact changes in your scenarios? That's it. I hope you to include that
Okay.
question to find out.
Thank you very much for the question. That I also would like to touch upon that issue. For our new project, that we also try to focus on the lifestyle change as one of the key indirect drivers. So we are going to use the agent-based model to quantify some of the behavior change, like consumption patterns or dietary change. So these are something we are now planning to further advance our studies to quantify the lifestyle change. And then so such kind of how to approach the lifestyle or the health or dietary change, such kind of the change of the indirect driver is still the kind of frontier for our environmental system research, I think. So we'd like to connect, try to explore that field, and also as Hashimoto Sensei mentioned, that the collaboration with the private sector is still largely lacking in Japan also. So we also would like to expand our collaboration with the private sector. So thank you very much.
Thank you very much, Sato Sensei. So everybody, thank you very much for joining for the Japanese session. I want to hand over to the Chinese session, and maybe you can find the link of the Chinese session from 10 o'clock our Japanese time. But anyway, thank you very much for joining again, and also I want to give the big hand to all of our panelists and also the contributors today. Thank you very much. Thank you. ありがとうございました。
Thank you very much.
Thank you very much.
Thank you so much. はい、ありがとうございました。
はい、どうもありがとうございました。失礼いたします。
はい。またよろしくお願いします。